In this video, I'm going to talk about Le Chatelier's principle and how it affects the chemical equilibrium, and this is from section 15.6 in your book. So Le Chatelier's principle is pretty straightforward. It just states that when a stress is applied to a system in equilibrium, the system will respond by shifting in the direction that minimizes the stress. That is to say, it will move towards the reactants or towards the products, depending on what the stress is. Okay, so there are 4 different stresses that we can perform on a system at equilibrium. Okay, the first we have is just the addition of a reactant or a product. And this is to say, if we physically add more of either reactant or product to the system, it will affect the equilibrium. Another one, on the flip side of that, is the removal of reactant or product will also result in a shift in the equilibrium in order to reduce the stress of that removal. Okay, and then also the change in volume when you're dealing with gases here. The change in volume of a system will also introduce a stress on an equilibrium, and it will shift the equilibrium in order to accommodate. And then the last one we have is just a change in temperature. For any system at equilibrium, will change up the equilibrium itself, and it will shift one way or the other. So take this equilibrium that I have down here as an example. In the first part of this time lapse that we see along here, we have an original equilibrium mixture, right? So this value that you see right here, this is equal to K, right? The equilibrium constant. So what happens, so the K is 0.297 here. So what happens if we add some N2 to our system? Well, our Q is going to be knocked off a little bit from the K, right? Because we're no longer at equilibrium since we've added some of our reactant here. Okay, so it's going to have an overall Q of 0.173 right when you add that N2. Okay, now as you proceed, right, as you continue on down the reaction, it's going to shift the overall equilibrium towards the products in order to accommodate for the fact that you added reactant. Okay, so you're going to increase the concentration of your NH3, right? And then, once the system reaches equilibrium again, after increasing the concentration of your NH3, right, and decreasing the concentration of H2 as well, you're going to reestablish the K, the original K that you had from the first equilibrium, right? Because at this particular temperature, this particular system will always have the same value for the equilibrium constant. So in order to get to a general rule, let's take that same equilibrium system we were just working with. When you increase the amount of reactant that is in an equilibrium by applying stress to the system, right? If you increase the amount of reactant, or if you decrease the amount of product that's present within that equilibrium system, you actually end up getting to a situation where the equilibrium will shift towards the products in order to compensate for that stress, right? So if you increase the concentration of your reactants or you decrease the concentration of your products, you're going to have an overall shift toward the product side. Okay, now conversely, let's go the other way with this. If we have a decrease in the concentration of our reactant, say we remove reactant from the system, okay, if we decrease the concentration of the reactant, or if we increase the concentration of our product, right, this is going to result in a shift of going towards the reactant side here. So just by decreasing the amount of reactant that you have in your system, you will shift the equilibrium to compensate towards the reactants, forming more reactant in order to reach an equilibrium state again. All right, so let's take this new equilibrium system here. We have PCl3 plus chlorine gas going to PCl5 gas. Okay, so if I add some PCl3, what is that going to do to my overall equilibrium? It's going to shift it right. Okay, so if I have if I add some reactant for this particular equilibrium system, if I add some reactant, it's going to increase the overall system towards the products. Okay, so now let's do another one. What if we remove some PCl3? PCl3, okay? If we remove some PCl3, the overall equilibrium is going to shift towards the reactants, okay? If we remove some of the reactant in order to achieve the equilibrium concentrations again, right, or achieve the same Kc that we had started with, we need to decrease the amount of product and increase the amount of reactant. So we have to shift towards the reactant side. And then if we remove some PCl5, the opposite occurs. Remove PCl5, it's going to shift towards the product side in order to, again, to achieve the same Kc that you had started with. Or another way to say that is to achieve equilibrium again.